Hello students, welcome to today's lesson. I'm teacher Alice and we are still looking at Form 3 topic 2, the mole. And in our previous lesson we looked at direct titration. So this is part 11 and we are looking at more examples on direct titration. So this is example 3 and this is the question. We are told that 25 centimeters cubed of 0.5 molar solution of potassium carbonate were neutralized by 15 centimeters cubed of hydrochloric acid. Calculate the concentration of the acid in 1 moles per liter and also in grams per liter. So for our question, we have potassium carbonate as our standard solution. We have the volume and the concentration of potassium carbonate. So this one will help us to get the concentration of the acid, of the hydrochloric acid. So the first thing, we get the number of moles of potassium carbonate. So since we are given the volume and the concentration, we can find the number of moles. So 1000 centimeters cubed is of potassium carbonate is equal to 0.5 molar. That is the concentration that we are using. So we ask ourselves, what about 25 centimeters cubed of potassium carbonate? So what we just do here is to cross multiply 25 multiplied by 0.5, then divide by 1000. So the number of moles of potassium carbonate in this solution was 0.0125 moles. Then from there, the second step, we saw that we are writing the equation for the reaction between potassium carbonate and hydrochloric acid. So the equation is here, it is balanced. So we have 2 moles of hydrochloric acid are reacting with 1 mole of potassium carbonate to give us 2 moles of potassium chloride, water, and carbon dioxide gas. Now, from this equation, we have seen that 1 mole of potassium carbonate is reacting with 2 moles of hydrochloric acid. So this is the relationship we are going to use to get the number of moles of hydrochloric acid that was used in this reaction. So if from the reaction we have seen 1 mole reacting with 2 moles and 1 mole of potassium carbonate is 0.0125 moles, as we have seen in the first step. So we ask ourselves, what about 2 moles? So here is just a matter of multiplying 0.0125 multiplied by 2. So the number of moles of hydrochloric acid that was used in this reaction was 0.025 moles. Now, having the number of moles, we can get the concentration in moles per liter. Okay, so we were using 15 centimeters cubed of hydrochloric acid. That is similar to the 0.025 moles. So 15 centimeters cubed was equal to 0.025 moles. Then what about 1000 centimeters cubed? That is 1 liter. Okay, so we cross multiply 1000 multiplied by 0.025, then we divide by 15, and that is what is giving us 1.6667 moles per liter. Okay, so that is simply how we calculate the concentration in moles per liter. We just find the number of moles of the standard solution. Then from the equation, from the reaction, we write the equation and see the number of moles of the reactants that will give us the products. So according to the number of moles or the ratio of the moles, we can be able to find the number of moles of the other solution. So from now, after getting the number of moles, we can equate it using the volume that is used and compare it to 1 liter, that is 1000 centimeters cubed. So that is how we get the concentration of hydrochloric acid in moles per liter. Then part B, we are required to find the concentration in grams per liter. So having the concentration in moles per liter, we just have to multiply the concentration by the relative formula mass. So to find the relative formula mass of hydrochloric acid, we have hydrogen having a mass of 1 and chlorine having a mass of 35.5. So the relative formula mass or the molar mass of hydrochloric acid is 36.5. So concentration in grams per liter, we multiply concentration in moles per liter, that is, we had 1.6667 moles, then multiply by the relative formula mass or the molar mass, which is 36.5. So the concentration of hydrochloric acid solution was 60 grams per liter. Okay, that was example 3. So let us look at example 4. We have 13.25 centimeters cubed of 0.05 molar hydrochloric acid neutralizes 12.50 centimeters cubed solution, which contains 3.5 grams per decimeter cubed of impure sodium carbonate. So we are asked to calculate the percentage purity of the sodium carbonate, and we are given the masses of the molar mass of sodium, carbon, and oxygen. So from the question, we have first to determine the standard solution. And from the information we are given, hydrochloric acid seems to be the standard solution since we have its concentration and its volume. So having its concentration and volume, we can calculate the number of moles present in hydrochloric acid. So we have 1000 centimeters cubed, or simply 1 liter, is equals to 0.05 molar. Then we ask ourselves, what about 13.25 centimeters cubed of the hydrochloric acid that we are going to use? So we multiply 13.25 multiplied by 0.05, then divide by 1000, which would give us 0.0006 moles hydrochloric acid. The second step is to write the equation for the reaction between sodium carbonate and hydrochloric acid. So this is the equation, and make sure it is balanced. So after writing the equation and balancing it, we get the mole ratio. So we can see that 2 moles of hydrochloric acid are reacting with 1 mole of what? Of sodium carbonate. So what about if 0.00006 moles are for what? Are for hydrochloric acid. So to get the number of moles for sodium carbonate, we have to divide this number of moles by 2. So 0.0006 divided by 2 was giving us 0.0003 moles. So the number of moles of sodium carbonate that reacted with hydrochloric acid was 0.0003 moles. Now we don't need the concentration. Sorry, we don't need the number of moles. We get the what? We get the concentration. So to get the concentration, we have to compare. Now we have 12.50 centimeters cubed of sodium carbonate was used. So this is equal to 0.0003 moles of sodium carbonate. So we ask ourselves, what about 1 liter? So what about 1000 centimeters cubed? So after we multiply there, we have 0.024 moles per liter. So that was the concentration of sodium carbonate in this reaction in moles per liter. Now, to get this in grams per liter, we have to multiply by the relative formula mass. So the concentration in moles per liter multiplied by the relative formula mass will do what? Will give us the concentration in grams per liter. So the relative formula mass of sodium carbonate is 106 grams. So concentration in grams per liter will be 0.024 moles per liter multiplied by 106 grams. So this will give us 2.544 grams per liter. And remember, 1 liter is equals to 1 decimeter cubed. So this 2.544 grams per liter can be written as 2.544 grams per decimeter cubed. So now to calculate the percentage purity, we have to take the concentration that we were using, that was 2.544 grams per liter, over the percentage purity, which was 3.5. Sorry, not the percentage purity, the purity of the sodium carbonate, which was 3.5 grams per decimeter cubed. Then to convert it to percentage, you have to multiply by 100. So the percentage purity of the solution we were using was 72.69%. Okay, that is how we calculate the percentage purity from concentration. So this is how we approach these questions on direct titration. Most of them will be based on, or will be relating to these examples, so you can be able to answer any question on direct titration. Okay, that will be the end of our part 11. So we are now going to look at part 12. So see you again in the next lesson.